This skill has questions about Le Chatelier's principle. Le Chatelier's principle tells us that if a system is initially at equilibrium and a change happens to the system, the position of the equilibrium will shift to counter effect that change. So equilibrium will shift to counter a change. Le Chatelier's principle is only applicable when the system is at equilibrium initially. So let's go ahead and practice applying Le Chatelier's principle on these problems. So in this question, we have a container with fictional substances Z, Q2, and ZQ3. It's initially at equilibrium. That's good because that means we'll be able to use Le Chatelier's principle. So we have 2 of Z, which is a liquid, 3 of Q2, which is a gas, and 2 of ZQ3, which is aqueous. In other words, it's in solution. We're then told the system is stressed by removing some Q2. So that's the stress or the change that is happening. First, we're asked, what state is Q2 in? So we can see from the question, Q2 is a gas. We're asked, how does removing some Q2 affect the concentration of Q2? Now, when we're talking about concentration, that applies to gases and solutions. So if we remove some of the gas, we know the pressure of the gas is going to decrease, which means our concentration of the gas is going to decrease. If we remove some of a compound that's in a solution, we're going to be decreasing the concentration of that solution. However, if we move some liquid or we remove some solid, we're not actually changing the concentration of the liquid or the solid. They've got the same density, the same number of particles in a given volume. We're just changing the amount of them that we have. That doesn't actually affect the concentration. So how does removing some Q2 affect the concentration of Q2? Because Q2 is a gas, it means that our concentration of the gas is going to decrease. So the concentration is going to decrease. Okay, so that was our stress. That's what happened. Our concentration of this has decreased. So what needs to change to counteract this stress? So this is where Le Chatelier's principle comes in. Le Chatelier's principle tells us equilibrium will shift to counter a change or to counter a stress. So if our concentration of Q2 has decreased, we need the backwards reaction to increase in its rate so we can make some more Q2 to make up for the fact that that's decreased. So we need to have an overall reaction in the backwards direction. So what needs to change? We need the concentration of Q2 to increase, since we need to counter the change that's happened. In order to make that happen, the backwards reaction should be favored because it produces Q2, and we need to increase the concentration of Q2. So if the backwards reaction needs to be favored, that means equilibrium will shift to the left towards the reactants. Let's do one more question of this type. This time, again, we have fictional substances E3Q, LT, E2T, and L3Q2. We're told it's initially equilibrium. That means we can apply Le Chatelier's principle. So in our equation, we've got E3Q and we're told it's a liquid. We've got LT and we're told it's a gas. We've got E2T and we're told it's a solid. And we've got L3Q2 and we're told it's a gas. We're told the system is stressed by removing some E2T. So E2T is here in our equation. And E2T is a solid. So the next question asks, how does removing some E2T affect the concentration of E2T? Now remember, concentration only applies to gases and solutions. If we remove some of a solid, the remaining solid has the same concentration, we just have less of it. So removing some E2T doesn't affect the concentration of E2T because it's not a gas or a solution. So the answer here, how does removing some E2T affect the concentration of E2T? The concentration of E2T remains constant. There's no effect on the concentration by removing some of that. Okay, so what needs to change to counteract this stress? Well, actually, because the concentration of E2T remains constant, there is no stress happening in this situation. So there's no change required. So which direction should be favored to make this happen? Well, neither. We don't need to favor either direction because we don't need any change to happen. So which direction will the equilibrium shift? There's not going to be any shift. So in this skill, it's really important that you think about the state that the substance is in. If it's a gas or a solution, then changing the amount of it is going to affect the concentration. And then changing that concentration is going to affect the equilibrium based on Le Chatelier's principle. If we increase the concentration of something, we're going to need to shift the equilibrium so that the concentration will decrease afterwards. And if the stress we have is that decrease the concentration of something, then the equilibrium is going to shift so that its concentration will then increase. However, if we have a solid or a liquid, changing the amount of it doesn't affect the concentration. So there'll be no change required and no shift that happens.